Specific heat is basically how much energy is required to raise an object's temperature. So how much energy do we have to add to whatever we've got in order to raise the temperature? And officially, the specific heat of something is the amount of energy required to raise the temperature of a 1 kilogram of that substance by 1 Kelvin. And the values for C are in a table. You just look them up and you get to have that on the test, so don't like freak out. Okay, I call the specific heat formula the Mcat formula because this kind of looks like an A, but your Q is the heat transfer, the M is your mass in kilograms, the C is your specific heat value. You just look that up in the table, and then your delta T is just your change in temperature. So that's going to be your final minus your initial. Okay. This is a specific heat table. You can see that there's specific heat for a lot of different objects. Okay, so on your test, you'll have this table. It's on the formula sheet, and you'll just pick out whichever one you need. Okay, so when we turn on the hot water to wash dishes, the water pipes have to heat up. How much heat is absorbed by a copper water pipe? So this is copper, and it has a specific heat of 385. I went ahead and looked it up for you guys, so you don't have to worry about it. And it has a mass of 2.3 kilograms, and the temperature is raised from 20 to 80 degrees Celsius. So let's write the things that we know. We know our mass, and it's 2.3 kilograms. It's already in kilograms. We don't have to worry about changing it. We have our initial temperature of 20 degrees Celsius. We have our final temperature of 80 degrees Celsius. And when I get to this point, I go ahead a lot of times and I just go ahead and I calculate my delta T because I'm here anyway, so I might as well deal with it. Your delta T is not always the big minus the small. Sometimes it will, if you're lowering the temperature, it's actually going to be the small minus the big. So don't just always do big minus small, even though that's how it is in here. You should always do your final minus your initial. Okay, we have our C, which is our specific heat, and I just looked this up in a table. Okay, I didn't like memorize it or anything like that. I just looked it up in a table. And then they want how much heat. Okay, so that's the Q. Okay, so I'm going to go ahead and I'm going to write my specific heat formula. I call this the Mcat formula, and that's just because it looks like cat, but I mean you don't have to call it that. That's just what I do. And I'm just going to go ahead and I'm going to plop in my numbers. And that's just supposed to be multiply. I just don't want you to think it's an X. And then our delta T is 60. Okay, so we get this kilogram. This kilogram crosses out with this one. And this Celsius crosses out with this one. So, so you're good to go there. You're good to go with your units. You'll have the right units of joules when you finish, if you're one of those people that worries about units. And so when I multiply all of these things together, I get 53,130. And that's a big number, and that's okay. You also might see answers written like this. You see me doing this? And that's okay. So you may see answers either way. Either one of these would be right. And that's all you have to do for a specific heat problem. You just plug in your numbers. And remember, you get this C from a table. This is not something that you just like make up out of thin air or you have to memorize. It's in a table. And the next slide I'll show you kind of what the table looks like. So the tables look like this. This is our specific heat of copper. This is the one we were using.